Question 1302 LeetCode deepest leaves sum. So given the root of a binary tree, return the sum of the values of its deepest leaves. In example 1, we have this binary tree and the output is 15, and that is the summation of 7 plus 8. So the deepest leaves in this case are 7 and 8. So this does not include this leaf node here, so leaf node 5, which is one of the cases you need to watch out for. It only concerns this level down here. So there are two approaches to this. We could use a breadth first search and populate a result array and then reduce the last array within the result array. And by reduce, I mean just add up 7 and 8. Or we could use a DFS approach, which is what we're going to be doing today. So what is the main thing we need to keep track of when we DFS this entire tree? We need to keep track of the level we're on. So we will be passing into the DFS function the current level. And then when we go down within the binary tree, we're going to add 1 to the level. So we're going to have a variable called sum, which is going to be initially set at 0. We're going to have deepest level, we'll call it deepest L, which is also going to initially be set at 0. And at this first level, at root, we are going to set the level as 0. Okay, so with DFS, we need to add a base case. And in this case, if root is equal to null, we can just return, right? Because there's no other level to search, so we won't be able to add any value. So if, for example, we get to down here and we reach null, we just return, and then we search the rest of the tree. Okay, now the recurrence relation, what we're going to populate this DFS function with is a little bit more complicated. So at this level, we have 0. When we move down to this level, we're going to have 1. Okay, so we're just adding on to the levels. But we need to check whether this level here is equal to the deepest level. And if it is, then we update the sum to equal the value of the root. So in this case, sum is going to be updated to 1, and then we go down to the next value. So that's one check. So if the level is equal to the deepest level, carry out this bit of code, which will be the sum plus the root value. Okay, and at this level, we'll carry out different logic. So based on this level right here, if this is greater, so if level is greater than deepest level, then we need to reset deepest level to equal this level. So deepest level will go to 1, and then we need to set the new sum to equal 2. So we're forgetting about this value up here now because we have a new level, a new deepest level within our search criteria. And then we just repeat this process. So we go down to this level. So let's just do the left side first. We're at level 2. We check, is the level greater than the deepest level? It is indeed. So we update the deepest level, and we also update the sum to equal the value at that current node, which is equal to 4. Now we're at this level, so that's level 3. This level is greater than the deepest level, so we update the deepest level to 3, and then we change the sum to equal this node's value. So that's going to be 7. Then we have null, so we just return on that, and then we carry out the search criteria down this side. So we carry it on the right side of 2 because there is another search area. And this is at level 2. Is level 2 greater than the deepest level? No, it's not. So we don't have to do anything here. So we carry out the search criteria and we go down the right side. So at this level, level 1, that's not greater than deepest level. So we carry on down. Level 2, that's not greater than deepest level. Level 3 at node 8, this is equal to the deepest level. And as we said at the start, if the level is equal to the deepest level, then we just add on to the sum the current node's value. So it would be 7 plus 8, which equals 15. And then we can finally return this answer here. So for our complexity analysis, time complexity is going to be ON, since we have to visit each node exactly once. So this is an upper bound, and then space is going to be OH. So let's start off by initializing our variables. So let sum equals 0, let deepest level equals 0. Then let's create the function, DFS, pass in root and level. And when we call it, root is going to be root and level is going to be set at 0. So within any DFS call, we need to have a base case. So if root is not available, we can just return. And then we need to carry out the logic within this DFS function. So if the level is equal to the deepest level, we add on to the sum. the value at root. Else, if level is greater than deepest level, we update the deepest level to equal level, and we set the sum as the value at root. And then we carry out our search down the left side. Remember to update the level, so we're going to add 1 to the level, and remember to go down the right side as well, because we want to carry out the check within the whole binary tree. And then we can just return sum and check to see if this has worked. Okay, so it's been accepted. Let's try submitting it. And there you have it.